In this video, I'll be discussing the OR gate, and I will be setting up a circuit to work with the OR gate. So the OR gate that I have, the information that we have in the lab manual for the OR gate is very limited. So this is pretty much all that you have. You have the symbol and the code 74LS32, but there's a little bit more to it. So I have the chip for the OR gate, which I have already set up in the circuit, and I had to find the code on it. So the code on it, I'll show you. Based on the code, this is the document, PDF document that I found online. So the code on it is this one. It's S774LS32. And that is, so with that, I was able to find this PDF document. This is, it's an old document from Texas Instrument, and this is the document that I will be using to, that I have used actually to set up my circuit. There are two configurations for the chips that we can see here. So mine is the one at the top, okay? And I was able to determine that by looking at the shape, but also by looking at the code right here. SN74S32. LS, that is 32. So SN74LS32. So that's the code that corresponds to this configuration, but it's also the shape that helped me identify the correct one. So that's the code and the shape. So notice that I need to power this chip, and you can see that this chip has several pins that are labeled, and based on these on the labeling, I was able to use the chip. So the first thing is the powering up of the chip. If you don't power up the chip, you will probably not get the results that you're looking for. At least the way the operation of the chip is based on some conditions. So the first thing is we need to give power to the chip. So VCC here is where we're gonna apply 5 volts to power the chip. And there's also a ground here that is going to be used to ground the chip. So all this information is available in the document. There's more to this chip. So this chip contains a couple of gates, and we can see these pins are there for the gates, input or output. I don't know, so I don't know now. I will have to look at the document in order to be able to determine what each pin stands for. So this is an OR gate, and we're given here the function table or the logic table. So A, B, so A is the input, B is also an input, and the output is Y. So the OR gate, the way it works is that if you have either one of the inputs high, you will get a high. So if we look here at the table, when A is high and B, the X stands for anything, whether it's a low or a high, you're going to get a high at the output. Second row, it's the same thing. If you have B high and A, it doesn't matter whether it's low or high, you're still going to get a high at the output. If both of the inputs are low, then you're going to get a low at the output. So we're going to see how that works. So the low and high in our experiment, the low stands for ground, and the high stands for, so ground is 0 volts, and the high stands for 5 volts. So now, in order to identify my pins, this diagram here will allow me to to identify the pins. So 1A, 1B are inputs, and 1Y is an output. And 1A, if you look next to 1A, you have the pin number 1 between parentheses. And 1B, in between parentheses, you have 2, so that's pin 2. And if we look on the right here, 1Y, between parentheses, we have 3, so that means pin 3 is the output. So that's how I'm gonna identify the inputs and outputs. So if we go a little bit below, below 1A and 1B, we see 2A and 2B. So those are inputs. And the pins are identified in parentheses. So 2A, for example, the pin number is 4. 2B, the pin number is 5. And if we look at the output, it's 2Y, but the pin is 6. So this diagram here will allow me to identify the inputs and outputs of each logic gate. So you have a diagram here, a logic diagram, where we represent the symbol of OR and we represent the inputs and outputs. So 1A, 1B, 1Y, 2A, 2B, 2Y, but those are not the pins. Those are we're just identifying the inputs and outputs. The pins, you can find them by looking at this diagram. So, so what I did is I identified, obviously, the inputs and outputs. So I'm going to be using 1A and 1B, and I'm going to be using 1Y, and that's it. I won't be using any other gates. So the inputs and the single output for the OR gate that I'm going to be using. So if we turn here and we look at what I have my chip, and I have, so this pin right here, which is pin 14, this is connected to pin 14, and there's 5 volts connected here, right here. So that's pin 14 connected to 5 volts. And then below here I have ground. That's pin 7. So pin 7 has to be grounded, and pin 14 has to be at 5 volts. So that will allow me to power my chip. And notice this right here. This right here. I have positioned my chip so that I have, you notice this right here, this dent, semicircle, so that when I look at my chip like this, I have exactly what I have. I have exactly, so this is VCC, pin 14, and this is pin 7. So the reason why I positioned it like this is because when I look at it in the document, I don't get confused. I know that at the top I have pin 14, and here it's 7, and I have 1, 2, 3. So I don't get confused with the diagram. So again, I have this is powering, this is the VCC, this is powering my chip, and this is the ground, and I'm going to be using pin 1, 2, and the output. So my output is connected actually here, which is connected to a multimeter, and my 2 inputs right now, pin 1 and pin 2, those are my inputs, and they're both now connected to 5 volts. So this is 5 volts right here. So I'm using obviously a power supply to power up my chip, and I'm also using a multimeter to measure the voltage at the output of my chip. So I am supplying 5 volts to my breadboard. So there's 5 volts, so you can see here, that is being supplied to my breadboard. And I am measuring the voltage at the output of my gate, of my OR gate, with the multimeter. So I have this measuring the 5 volts. So this clip is connected at the output of my OR gate, and this clip right here is connected to the common, or the ground if you like, of my circuit. So I get 5 volts because the reason is because both inputs here are high, or 5 volts. So what I'm going to do, I'm going to take the pin 1 and I'm going to ground it. And you're going to see it's not going to change my output. And so that makes sense, because OR gate, only one of the 2 inputs has to be high. Now what I'm going to do, I'm going to take pin 2 and ground it, and you'll see that that will change my output. So it did change my output. Now my output is 0. So what I'm going to do, I'm going to make pin 2 high. Let's see if it changes anything. If it changes anything, and it does. So now I have a high. So remember that in order for the chip to work properly, you need to supply 5 volts to the chip. If you don't, then you may not get the correct results.